Hello, my name's Julian Edgar and I'm the author of the book Modifying the Aerodynamics of Your Road Cars. What I want to do in today's video is talk about the internal aerodynamics of the engine intake system. And I cover this in a chapter in the book. I sort of snuck it in, even though it's more to do with engines and external body aerodynamics. So what am I talking about? I'm talking about developing a high flow intake system so that pressure drops through that intake system are minimised and as much therefore of atmospheric pressure as possible can get right to the intake manifold. And what I've done here on the whiteboard is I've shown a stylised intake system. And let's have a look at that intake system. It starts off with the intake system to the filter box, and here I've drawn a bit of a bell mouth. With the techniques that I'm going to describe, you can actually measure and see if that bell mouth actually makes any difference. So after the filter, the air flows through an airflow meter. You might have a map sensed car, in which case the airflow meter won't be there. And then it gets to the throttle. I'm not going to cover the system after the throttle, which is very much about tuned resonant behaviour. We're not covering that in today's video. So as the air flows through this system, there are restrictions that it must pass through. Those restrictions can be indicated by pressure drops. In other words, if you can measure a pressure that is lower than atmospheric at any of these points, it means there's a restriction and that's caused that pressure drop. So what do I mean? Well, let's put a pressure gauge there. Now, if that pressure gauge, perhaps I should show it with a needle and a sweep, if that pressure gauge shows a negative pressure, a tiny vacuum, it means that not all the air is getting through the intake and the filter that possibly could get through. So there's a measured pressure drop. Now, you might say, oh great, I'll just connect a normal vacuum boost gauge and that'll show that. It won't, because it's not sensitive enough, not unless your intake system is terribly, terribly restrictive. What you need instead is a magnehelic gauge, and I talk about these gauges extensively in these videos for measuring aerodynamic pressures. If you get one with a slightly higher full-scale deflection, a slightly higher value it can read to, you can actually measure these pressure drops through the intake system. So let's put some numbers to it. Let's say that this is showing minus 4 inches of water. In other words, the pressure is 4 inches of water below atmospheric, and we measure small pressures in inches of water. Let's now connect the gauge here. We just move it. We just connect it to the intake system with a rubber or plastic tube, and we seal up that little hole and we move it and we connect there. Let's say that shows minus 6 inches. Now, I hope you can see that if this one shows minus 4 and this one shows minus 6, there's 2 inches of pressure drop across the airflow meter. So we can see how much pressure drop occurs across each part of the intake system. Let's connect it here. And let's say that's minus 1 inches of water. Oh, didn't finish my gauge, did I? They're getting more and more random as I draw them. So this intake system is causing 1 inch of water pressure drop. The filter is therefore causing 3 inches of water pressure drop, and the airflow meter is causing another 2 inches of water pressure drop. Now, here we have a total of minus 6 inches of water pressure drop. Now, that's actually a fabulous intake system. Anything that's better, that's a smaller number than minus 10 inches of water is typically very, very good. And in fact, it's very hard to improve. But when you measure the total pressure drop, and always at full throttle, full power, that's where you'll get your maximum. When you measure that maximum pressure drop, on some cars, it's 20 or 30 inches of water pressure drop. And that's a severe restriction. On any car where you can measure a pressure drop of that sort of magnitude, 20 or 30 inches of water, by making improvements to the intake system, you can gain measurable power at the wheels. If it's only minus 10 inches of water pressure drop, there's probably not a lot you can do. Incidentally, I've shown here minus 3 inches of water pressure drop across the filter. It's often a lot less than that. Typically, if you measure a standard good condition filter in the factory airbox, the standard airbox, you'll find perhaps only 1 inch of water pressure drop across it. I never change filters to high performance filters, high performance in inverted commas. Typically those filters have less filtering capacity, more rocks get into your engine, and if you're talking about 1 inch of water, even if they drop the pressure drop to 0, which they never will, it's only 1 inch of water. 10% of the pressure drop in a good system and maybe only 3% of the pressure drop in a system that's not so good. Changing the filter might be easy, but in the real world of actually measuring flow, it typically makes an irrelevant difference. And the danger of not filtering the air going into your engine, as well as in fact the standard factory filters it, I think is not worth the risk. So we can use a gauge to measure through the intake system at a succession of points what the peak pressure drop is. By doing some very simple subtraction, we can work out which components on the intake system are causing most of that pressure drop, and then we can look at improving those particular areas. So for example, in many cars, believe it or not, the intake to the airbox is too small. It's causing a pressure drop. And if you fit a larger intake to the standard airbox, you'll see often an improvement. And you can measure, of course, what that improvement is. On some cars, and not nearly as many as people think, the airflow meter can be causing a restriction. The old vane airflow meter, which everyone thinks is so restrictive, is actually not very restrictive at all, because at peak power it's fully open and it's posing less restriction. It's just an open rectangle, the vane's right out the way, it's posing less restriction than a hot wire dangling in the airflow. So with these techniques you can actually measure and find out what's really going on, not what people imagine is going on, and you make changes and actually measure what those changes are. Just one warning though, the measured pressure drop will depend on the diameter of the tube. If you, for example, for some mad reason went for a smaller diameter tube, there'd be a faster airflow through it, the pressure drop would be measured much higher, disproportionately higher to the actual restriction that's going on. So it's best to stick to a single point and measure pressure drops at that point. For example, either side of the of the air filter in the filter box, where you don't change the filter box, you'll be able to measure improvements on the intake to it. That's a subtle point which I do cover in detail in the book. And to remind you, the book's called Modifying the Aerodynamics of Your Road Car, and I'll have a complete chapter where I talk not only about streamlining, aerodynamically optimizing the intake system to the engine, I also talk about picking up air at an aerodynamically high pressure point. I've covered that in another video, but typically you can get a few inches of water pressure back from the aerodynamic force of the air being pushed in. So for example, more than make up for the restriction of the air filter. But that's another video, but it is also covered in that chapter in the book. So remember, test, don't guess when it comes to modifying intake systems. And with a reasonably cheap gauge, especially cheap second hand, you can measure things quite precisely and work out, one, whether or not a change would improve things. In other words, if the system is already really good, don't bother changing it. And number two, if the system does need improvement, which components within that system you should really modify to get better results. Thank you.